2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. See that problem board, that problem is easy. Thanks to Mr. Ng. Yeah.
Hey guys, let's go over quiz number 3, 1.1 to 1.2. Which graphs represent a quadratic? So a quadratic function would be something like to the second power, and it looks like a u or an upside down u if it was a negative x squared. A is not. This is called a cubic polynomial, which we're going to learn later. Our correct answer is B. This is a quadratic. Okay, C, although it kind of looks like it, you'll notice that has extra bumps in there. So it's not C. D is a quadratic. So this one tells you to select all that apply. And E is not. This is an absolute value. This one has the equation y equals the absolute value of.
All right, let's go over question number 2. Find the average rate of change for the function over the given interval y equals x squared plus 9x between x equals -3 and x equals 7. So this is my x1 value. This is your x2 value. We're going to put in x equals -1 into our equation here. And we'll do it separately for the x2 value. So let's put in -3 and see what happens. -3 squared plus 9 times -3. So this will become +9 minus 27. This will give us a -18. When I put in -3, I get -18. Let's do that for this one. 7 squared plus 9 times 7. So this will get me 49 plus 63. And this will get me 112. So when I put in an x value of 7 into the function, I get 112. We've just evaluated separately. Now let's put into the slope formula. M equals y2 minus y1 over x2 minus x1. I'm going to go ahead and make sure I have this negative sign. Common mistake for students. My y2 value is 112. My y1 value is -18. My x2 value is 7. And my x1 value is -3. If I add those together, I'm going to get 130 over 10, which is 13. Now, I made a mistake in that 13 is not one of your choices, but I decided not to grade this problem for version B. For question number 3, what are the real roots of the quadratic equation graphed below? Real roots is when it intersects the x-axis. Remember, their other names are called solutions. They're also called x-intercepts. They're also called zeros. Now this one only crosses at -4, and that's our answer. This is what they call a double root, so you would say x equals -4 and x equals -4, or you can also say a multiplicity of 2.
Consider the quadratic equation. Y equals 2x squared plus 12x minus 3. Well, I look at my folder and I recognize no parentheses. So if it has no parentheses, this is standard form. And we were working on identifying the A, B's, and C's for quite a bit of time, right? We've even done that back in factoring. So A is 2, B is 12, and C is -3. Did you notice how here the A, B's, and C's are never x, or x squared, right? It's the numbers in front. Those are called coefficients. Coefficients. Okay, part B, what is the axis of symmetry? So it gives us an equation. Let's just write this equation out. Negative b over 2a. So let's just use my highlighter here. Okay, so I need the b value right here. So b is 12. And then we're going to use a value, which is 2. So let's write that out. X equals negative. The b value was 12, and 2 times the a value, which was 2. And let's just go ahead and simplify that. So x equals negative 12, and then 2 times 2 is 4. So did you notice I'm doing that negative sign at the very end? That's just my preference. 12 divided by 4. Remember, if you don't understand cross canceling in some ways, 12 is really 4 times 3. Right? So cross out your 4s. 4 divided by 4 is 1. So I cancel out that equals 1. So I'm left with x equals negative 3 is my answer. Let's highlight that.
For question 4b, we found in the previous problem x equals negative 3. And this is what goes into the middle of my graph. So from here, I think of the x number line, so negative 2, negative 1, negative 4, negative 5. You can put that into Desmos. I have a calculator here. So I'm going to go y equals, clear it, 2x squared plus 12x minus 3. I'm going to go to my table, look for negative 1. I got negative 13, negative 2, negative 19, negative 3, negative 21. You'll notice that is the lowest or smallest number, negative 4, negative 19, and negative 5, 13. So when I go ahead and graph these points, I'm going to go left 3 down, negative 13. A little bit hard to see. So left 1 down 13. Something like right there. Down left 2 down 19. Left 3 down 21. And then it's symmetrical, negative 1, left 4 down 19, and left 5 down 13. I also notice that this graph will have a y-intercept of a negative 3. So this is standard form, no parentheses. It's going to go through negative 3. And then just use a color pencil or a pencil, and you want to make sure that it is a smooth parabola, like so. And that's what our graph looks like. All right, let's say in Desmos, I want to graph that question. So y equals 2x squared plus 12x minus 3. You'll notice the graph doesn't fit, so if you click on the gear icon or the circle, click on the table here, and then if you click on the magnifying glass, that'll zoom into the points that you want. But if you zoom out on your graph and you click on the vertex, the minimum, you'll notice that this is actually question 4b. This is your axis of symmetry. So x equals negative 3. So if I put in -3 and switch all these numbers. And now let's graph it. And I want to show you something else. So if I actually just graph x equals -3, that shows me my axis of symmetry here. So that's how you get a table of values and your graph using Desmos.
Hi there, are you tired of your old sauce being barbecue sauce, ranch dressing, Friends dressing? Well, boy, do we have the product for you. As we like to call it, the mathematical sauce. We have different kinds of flavoring. One is, for example, we have 2+2 flavor, and we also have the 3x4 flavor.